Thank you, Daniel. Thank you very much. It's working? Perfect. Great. Yeah, 20 years also with the project with some breaks. Today I'm talking about real-time text. Wolfgang already had a talk about that in the morning, about emergency calls in particular, and I will extend a bit on that. Real-time text for voice over IP infrastructure. First, a few one-two slides, just a bit about us. We provide web RTC service consulting in this area, do a lot of open source development. We one of our mottos is that we integrate almost all of our extensions, all of our work, what we have done with the customers in the open source project, and it's really good to continue this way. We provide consultancy, as said, integration, different areas. Kamailio, also recently with Asterisk and other projects. Our customers are mainly in Europe, in the US, Canada, also a bit in Asia, Middle East, and we are independent as a proper open source consultancy, and we consult them mostly in the Kamailio and Asterisk field. Okay, this whole project started 2024 when a customer from Germany contacted us and asked, hey, there's these real-time text requirements coming up. Do you like to have a look into it? And I was knowing about it. I was pretty naive. I said, yes, of course. Let's go for it. And it turned out to be a quite interesting journey, interesting challenge, and took also, unfortunately, a little bit longer than we all expected. But here we are now, and I think we have a good state, and I'm happy to present the current status. For the agenda, a quick overview. What is the real-time text in particular? You, of course, know all the WhatsApp, whatever, Telegram, Signal, different chat methods. It's a bit different. Motivation, legal requirements. Wolfgang, as I said, already presented a bit about that in the morning. I go over quickly the technical implementation of these real-time text, and cover a bit the implementation with Kamailio, and in particular also with Asterisk, and give an overview about the current status in Asterisk in particular, and next steps from our side in this project. As I said, it started in 2024, this whole phase, this whole project. We created the first version of the pull request in 2025, in the beginning of 2025. Now, here we are, one year later. I will talk a bit why it took so long. Some slides later, come back to it. It was a team effort. Everybody from the team sitting over there was involved. Many thanks for it. And it hadn't been possible without everybody working on it in some part or the other. And of course also thanks to our customers for sponsoring this work, and also for the patience during the delays. So what is real-time text? Real-time text is text transmitted instantly as you type. If you are used to like Slack, Teams, WhatsApp, whatever, you type, you press send, and then it ends up on the other side. Real-time text works differently. You type and it will send directly. So basically, similar as you talk, you can have a conversation directly. You can also delete real-time text that you have written. So it's real-time in a way that the receiver will see immediately the text that you sent. There are different technical means how to transmit real-time text based on different standards. Here in this talk, I will focus on one main standard, which is mandated also from the legal environment, from the legal regulations, especially in Europe. Why it's important to look into it, why it's necessary to implement the capabilities for it. Of course, the main audience are people that cannot really hear well, that are maybe hard of hearing. In the past, there were special devices or special apps, OTT apps, which were used from these people to communicate with other people. Of course, these special devices, they need to be installed in a place at your home. Special app needs to be installed from all the communication partners. This creates some barriers for the communication, and of course, we don't want to have it. We want to have it seamlessly integrated into the normal public telephony system. There may be also other people that prefer text-based communications instead of a voice or video-based communication for, I don't know, other reasons. Maybe they are just shy or whatever, right? So there are different motivations why this is important. Real-time text provides full support for international character sets. So we did tests with multiple languages. I think some Indian languages we tested. Of course, English, German, some other European languages we tested, and it works quite well with the Asterisk. There might be also emergency situations where it's not possible to speak, right? Imagine you have a burglar attacker in your house, and you want to call 911, 112 in Europe, and then you cannot really speak, but you can still type, right? And there's a standard from the European Union. It's also other regulation authorities. It's called total conversation, basically combining the video, the audio, and the text together, and this is the goal also to achieve. There are different regulations around this. I will share the slides later on. You can look it up. Basically, there are different regulations, accessibility requirements from the European Union, and then there's emergency number 112 regulation on the right side. These are basically the legal requirements in the EU for it. In Germany, there's Bundesnetzagentur, which mandated it in the current regulation 2.1, and other countries also have similar requirements, like in the US, FCC requirements, or in other European countries. It's all mostly boils down from this European regulation. There are different approaches in the EU. I think I'm not so much into the regulation side. Probably there are other people here in the audience that know more about it. But there are some older reports from EINA that present the situation. So some countries, like Germany, France, Netherlands, etc., they plan to integrate RTT as part of the national legislation and also in the core network. And some countries were a bit less patient, and they already standardized more or less some OTT apps on the mobile phone mainly to use it. The countries are moving in parallel, so even a country that has an OTT app will still mandate it in many cases to integrate it into the core network. And, which is important to know, the legal deadline, implementation deadline is 2027, so it's less than 1 year from now. And of course, it's overall changes are necessary. Wolfgang already, as I mentioned, presented in the morning. We need to change the core network. We need to change the user devices, and also the public service answer points, basically the centers which receives the emergency calls, also needs to be changed. This whole thing is going on for some time, so there is already a lot of support in devices. And just to show you how it looks like, some slides about some user devices. So this is the iPhone, what we see here. Android, it looks a bit similar. If you look into your Android mobile and look for RTT in the settings, or on your iPhone, look for RTT, there's a toggle then you can activate it, and it will be supported already, if the core network, of course, support it. If you have a phone call here, as seen on the right, you do the call, and then you can basically activate an overlay like a keyboard or whatever, and then you can chat over the normal PSTN network. For the testing devices, here I have some conversation just tested a few days ago. On the left side, there's a client called Easy Touch. It's a bit more modern. On the right side, it's a pretty old one, Tipcon. And but it works. You can see you can communicate over these clients as well. These are desktop-based clients sitting on your Windows or Apple PC or whatever. And for the emergency center for the PSAP, just on screenshot I found there are not so many publicly available, but here we have a US-based system 911. And here you see, okay, my husband shot himself. It's transmitted over real-time text. You have here the output from the emergency center and the feedback from from the caller, actually. Okay, great. So we know how it looks like and why we want to do it. So let's talk about techniques. We are a technical conference here in the end. So the good news is that real-time text calls are standard zip calls in the end. There's nothing really special about the zip call. It's just invite, 200 OK, acknowledge, bye. That's it. The text format is standardized in some ITU specification in T140. And the RTP payload for this specific text format is specified in RFC 4103. It's an older RFC, but it's pretty short. Actually, it's not a complicated format. There are newer developments like RFC 9071 for multi-party real-time calls, more recently published. I haven't been able to find an open source implementation of that yet. And from an RTP or media point of view, the real-time text calls are just using a dedicated text media stream. You know, there's an audio stream in most phone calls, then there can be a video stream, and now we have a third stream, just a text stream. We're using the normal SDP offer-answer mechanism, nothing fancy here, and also important, similar as with audio and video. You can have standalone text calls, you can have audio with text, video with text, and all kind of combination you can imagine. How does it look like from a header point of view, from a network point of view? Yeah, we have the standard sequence number, timestamp, synchronization source, and then the T140 encoded data. And as I said, it's pretty easy, not so difficult to implement. There are two different ways how to transmit the data. As you know, the RTP is transmitted over UDP, and UDP, we can have packet loss, these kind of things. And if we send text message, of course, we don't want to lose the text information, so there's an additional format with redundancy. So this is here on the next slide, and here we have basically the primary data, and then we have redundant data that we additionally add. And you can, in a standard way, basically you can have multiple, it's called generations, multiple copies of redundant data, and then multiple packets will have these redundant data. And even if one packet is lost, you still have access and can reconstruct it. Reconstruct the original message. From an SDP point of view, as I said, we just have the M line, not M audio. M equals text. On the left side, we have a normal real-time text call. T140 is the payload, basically in the packet. On the right side, we have the RTT with the additional redundancy. We have again a text line, and then the additional codec called RED, like real-time text redundancy. And in the last line here, this encodes basically the generations, or like the level of redundancy. Here in this case, a level of redundancy is 2. Okay, great. Now we know about the SDP and the RTP. How can we implement it? As you all know, probably, Kamailio really doesn't care that much about the media. It mostly depends on the user agent, so it's quite easy to implement with Kamailio. Just add the capability to the user agent, it will work. We did some tests. It seems to work with RTP engine as well. It's pretty easy to set up, and that's the easy part. And so if you're just concerned about the core network, you don't need to do much in the best case. The main issue is with the user agents. These are the user agents we are used for testing. The PJZip UA, since some months, also supports it now, which is great. It makes it much easier for testing. There's an old, more than 10-year-old client called Tipcon. And then there's Easy Touch from a Scandinavian company. Unfortunately, as I know, I might be wrong, but as I know, it's not free available. There's no open source version. So they set it as a commercial version, so you can contact them. And as I showed you, Android, Apple phones, of course, also support it. If you want to test it with a mobile phone, of course, you need to have like a mobile core or like a test IMS system. it's of course a bit more difficult. Yes, okay, about the Asterisk. As you might know, there has been an older zip channel stack, older zip stack in the Asterisk called ChanZip. There was an implementation in ChanZip. ChanZip, of course, it's now obsolete, it's not used anymore, not useful anymore, and we also tested it, it seems to be also broken. And since some time, we're working on a Chan PJZip implementation for this support, and this, as I said in the beginning, turned out to be more difficult than we expected. I've done quite a lot of PRs in my 20 years of experience with open source projects, and this is the longest and also the most difficult, I would say, PR I experienced so far for different reasons. I put a screenshot here. We have a lot of discussions in the PR. I think it would be also good sometime to, we resolved most of them, but it's still not merged, unfortunately, yet. So why it was difficult? The PR was based on a previous unfinished PR from other people. We needed to integrate it and to refactor it. This was really difficult. And then, of course, we need to integrate with many existing Asterisk parts. Why we based it on this existing PR? Basically this existing PR was there. It was already partly done. It was not pushed further from the original contributors for different reasons. Sometimes it happened. People, of course, maybe change the employee or lose funding or whatever reason. They did not continue merging it. We needed to integrate with many parts of the Asterisk, as I said. There are interesting choices in the Asterisk regarding some interfaces, internal integration, in my opinion. So this makes it challenging sometimes to really integrate new functionality into the Asterisk. It was really difficult to test because there were no good test clients, and the test clients also have bugs, and they are closed source, so you cannot fix these bugs so easy. So PJZip UA was really a blessing that we got it. But it has also bugs, unfortunately, but at least we can open a PR and hopefully fix it. As I mentioned, the testing was a challenge. We had also longer waiting phase, sometimes from our side, sometimes also from the Asterisk part or Asterisk project. And then there are multiple ways from the Asterisk side how you can implement it. There are different bridging modes. There are different ways it can be worked with audio, without audio, these kind of things. And also Asterisk changed their requirements from the PR side also several times, unfortunately. But now it works, as you can see here. Here I just did a test call a few days ago, and you see here type audio, and there should be also type text here, exactly. So now it works. This is a simple bridging. It works also for native bridging. So from that side, we are quite happy now. About the status, the main PR is complete from our side, I believe. And we created also an automated test suite based on PJZip UA. This PR is not yet published. It needs to be a bit polished and a bit cleaned up because there are some test cases which are still failing, unfortunately. And then basically a lot of things are already working. Some of them are not working for some client issues. We have one bug in PJZip UA regarding an asymmetric codec issue. It's listed here on the top. And there's also one issue with Asterisk regarding calls without audio, that there's no RTP in one direction anymore. I think this is probably a bug in Asterisk, but there are workarounds. You can just add an audio stream, for example, and then it will work. As I said, the native bridging and the simple bridging will work. We have done many test calls, automated and also, of course, manual with different clients. And we have interoperability with the different clients with T140, also with the RED. It will be, if one client doesn't support the RED, it will be also transcoded now. So it works quite well from that side. Sorry. For the PJZip UA issues, we opened some pull requests, no, sorry, some issue reports, some bug reports already. Pull requests maybe we need to do later. Haven't got any feedback yet from the project, but we will of course work with this open source project to get it addressed. With the Asterisk guys, we will also continue to work to finalize it and to merge it. And then hopefully it will be in Asterisk 20, 21, 22. Yeah, that's the main one. And of course also in the master for the upcoming stable versions. Yes. Okay. For future work, as I said, we want to get the PR merged. Right now, again, we are waiting from the feedback from the Asterisk side. PJZip UA, we need to wait also on the feedback there. And for the Asterisk audio issues, we will create another issue as well in the Asterisk bug tracker. And hopefully, of course, we will see it in production soon. And it will work great. Let's see. Great, thank you very much. That was my talk about that.
Okay, thank you, Henning. We have Lorenzo, you are the second. Just behind you was fraction of second faster.
Thank you for this session. It was quite informative. I have a couple of questions. One is how the deletions are communicated in the RTT.
Sorry, can you
the deletions of the text, like when you type something and delete the text, right?
If you delete it, it will be like the control character, like a backspace, basically. It will transmit a backspace.
Oh, okay.
Yeah.
And another question is regarding the redundancy mechanism.
Mm-hmm.
Is it proactive or like the old RTP world, you have to send a PLC notification and request for a redundant packet?
Not sure if I got it correctly, but if the question was how this redundancy works, basically you need to decide at the session setup time, similar like we do an audio call, you decide I want to do G711, I want to do G7222, right? Similar, you decide I want to do plain T140 or T140 with the redundancy added. And then, of course, you can send a re-invite later to change it during the session, standard zip procedures. But you need to decide during session setup, and then it will be applied, and you get always the redundancy.
No, my question is more about how the if a text is lost or if a packet is lost, like you communicate that to a redundancy payload, right? So is it requested through a packet loss indication, or like it is proactive? It is along the stream the redundant data is transmitted.
No, it's not proactive, so there's no retransmission or something like that. It's RTP over UDP, right? So there's no retransmission. Of course, like from a reporting level, you get the XRTP, like the RTP statistics, of course. Okay. And on the other hand, basically, how this works is that you have the packets, and then you add multiple layers of redundancy to one packet and the next one and the next one, right? And then you hope basically from 3 packets, 1 gets through, and then you will be able to recover it. Yeah.
Okay, thank you. Thank you so much.
Hi. I'm not sure if you remember, a couple of years ago I presented something where I basically integrated in Janus basically the WebRTC side of things of exactly this. So basically
nice blog post. Thank you for it.
Yeah. But it was where you use data channels instead of RTP, and so I took care of that. But I encountered the same issues that you had, the lack of proper clients to do proper testing, and so far. At the time, there was only TipCon available, which as you know is not really that. I mean, it implements stuff, but it's really basic in terms of stuff.
It has bugs as well, as I mentioned.
And PJZip did not support it yet at the time, which is cool to have. So a couple of questions on that. So how advanced is let's say the level of implementation of RTT there in case I wanted to experiment with that too for some testing? And aside from that, considering that you now have also an implementation and there are a lot of clients that are not available for whatever reason. So how open would you be to making some more interop testing? Because I'd like to revive that effort sooner or later. I just didn't have the chance to find any actual implementation that I could play with, basically.
It would be great to. I would be pretty happy to have like a test with Janus or whatever, right? To just have the Asterisk talking with the Janus. This would be probably great to see and to do. We definitely should do it. About the PJZip UA, I think it's much better from a standard point of view. So like things that the TIPCon1 is not doing correctly, they do correctly. Also, there's some stuff that the PJZip UA does which TIPCon1 doesn't like because they just didn't implement it. So it's more stable. On the other hand, they didn't seem to speak the redundancy, the RED protocol yet. We haven't been able to really activate it. It seems to be a bit broken, but the main T140, it works reliable, and yeah, just from the user interface, I mean, you know the PJZip UA, right? You have this text client. Of course, you can use the Python libraries and whatever for testing, but if you use this C client, it's not that nice user experience. And of course, this TIPCon1, it's a bit better, but it works well.
Okay, 2 more questions. One was a hand here, and then Wolfgang, and then we have lunch break, and before lunch break, some announcements.
So very simple question, like why Asterisk not FreeSwitch?
I mean, because the customer uses Asterisk. I mean, if there's some interest on the FreeSwitch side, we can look into it. Some other people can look into it, of course. Yeah, it was just the customer uses Asterisk right now, and this is what we use also for internal reasons for some of our products. So this was a bit easier. Yeah. Okay.
Yeah, Henning, thanks for that presentation, and it's great to see that things are getting implemented. I was talking about real-time text, I think, years ago. And my question is, do you have any experience with mobile devices?
Yes.
And do you see any differences in their behavior on creating bubbles on the user interface, things like that? And just before you answer, very important information, there is a Etsy plug test event taking place end of May, and that would be a great chance to test with mobile network operators and devices the real-time text.
Okay, great. We should talk about that, of course, later. About the mobile phones, unfortunately, I was not able to test it firsthand, but there were some people in this long PR that reported that it actually works with mobile phones in some earlier states already, so I think it should still work. I think that some people tested it with some Samsung Android phones, and it was working okay. It was working great. There are some issues. Actually, I just contacted one of the reporter some days ago. There were some issues, for example, when you have a re-invite and you add or remove the text capability, and then the other side doesn't really like it. How to basically do the negotiation in these cases. But in the end, it boils down a bit to testing, and then maybe some proper parameter on the Asterisk side. Yeah.
Okay, thank you.
Thank you
once again for all the contributions so far. Just don't